Okay, so here's a lab I do with my chemistry 30s. It is electroplating zinc onto copper. So to start off with, let's just talk about how this cell works in a zinc nitrate solution. So we actually will have this cell set up. We have zinc nitrate in solution, so zinc with nitrate. And one thing I emphasize with the students is even though this is in solution, we have those ions present. So we have zinc 2 positive, and you also have NO3 negative. In this case, it's just a spectator. It's there. It's just not doing too much. Then we have the zinc electrode, and in this case, that is going to be the anode, which we could figure out with page 7 of the data booklet. And we get each student a little piece of copper, and the copper is what's going to get plated, and plating always happens at the cathode. So this was our copper. So that's the first part. Now, in terms of an electrolytic cell, we know that the anode is connected to the positive part of the terminal, and the cathode is connected to the negative part of the terminal. So if we had a battery here, we could just connect those to the terminal and go from there. And now we're in solution. So as this cell runs, your anode is still undergoing oxidation. So zinc is going from zinc solid and turning into zinc 2 positive plus 2 electrons. So the zinc 2 positive would go in solution with the other zinc ions, and the electrons will move from the anode, go through the wire, and go over to the cathode. So just like any other cell, your anode is going to decrease in mass because it's breaking apart, and the cathode is going to gain those electrons. So the copper is just the site. It's going to get those electrons, and it's going to pull the zinc ions out of solution. Right, those ions and form zinc solid, and that solid will be deposited onto the copper, so the copper is getting plated with zinc. So as the zinc ions are added to solution, they're also coming out of solution to make the zinc solid. And the copper would be increasing in mass because it's gaining zinc metal. So that is how our cell is working. So if we start to look at the analysis of this lab, the first question is, the electroplating of metals is an example of what? That would be an electrolytic cell. Okay, so electrolytic meaning that any electrolytic cell has a negative cell potential and is non-spontaneous. That's why we must add in the power source to force the reaction. Now in the cell, copper is acting as the cathode, and the zinc strip is acting as the anode. And then in terms of oxidation and reduction, copper is undergoing reduction, and your zinc strip is undergoing oxidation. In question 5, looking at those half reactions, at the zinc electrode, you have zinc ions getting attracted to those electrons to form zinc solid. And the zinc strip, the site of oxidation, you have zinc solid breaking up into the zinc 2 positive and 2 electrons. Moving on to the next part, talking about the mass. Because the copper ornament is being plated, it is increasing in mass, and the zinc strip is undergoing oxidation, it's decreasing in mass. With question number 7, this is one that sometimes gets the students a little bit tricked or messing up, and it's asking about the zinc ion concentration in solution and what's happening to it, as in, is it increasing or decreasing or staying the same? So in this case, because your anode is breaking apart and adding into the solution, whereas your cathode is attracting it out of solution, we are at one point adding more, but then we're taking it out, so we're decreasing. So all at the same time, we would just say, I wrote same, I meant to say stay the same. Stay the same. So it's not increasing or decreasing, it is staying the same. And then the last one, what would happen if the wires were switched? If we switch those wires, that would be known as reverse electroplating. And instead of the cathode gaining mass, whatever was plated on the cathode would now break apart, and it would go back over to the zinc. So essentially we're taking what was plated off and putting it back onto the anode. So that's the first part with our lab. And then with this lab, I add on a question that used to be an old diploma question. And this one, it's asked, if you replaced the zinc anode with an inert electrode, what would happen? So now we have still zinc 2 positive, we have NO3 kicking around, and you have water, but we don't have any zinc solid. We're not going to include copper because copper is just our site of what's being plated. So within this reaction, zinc is still going to be an OA, but now on the other hand, we have no zinc solid. And if you look at your data booklet, your water will become an RA. So when we're looking at this and asking about what's happening, at the cathode, we still have that same reaction. We're going to have zinc ions that are in solution being attracted to the electrons that are coming over to form zinc solid. At the anode, though, we need to look up the half reaction for water. So this one here, so we'd have 2 water molecules, and we're just flipping it so it looks like oxidation to form, and that would give us O2 gas plus, I'm just trying to see this small little number, 4 hydrogens and 4 electrons. So then the next question is talking about pH of the solution. Within this, if it's asking about pH, we have to see hydrogen or OH ions, depending on what we have, but it usually will be hydrogen. If hydrogen is on the product side, like it is in the second half reaction, that means hydrogen is being produced. So if in your beaker now you are also getting hydrogen ions, your solution is becoming more acidic. So if you look at your pH scale and you're becoming more acidic, your pH is heading closer to 0. So what's happening to your pH? Your pH is decreasing because you're getting more acidic. If you had litmus paper, red would not turn but stay red, but your blue litmus paper would turn red. In terms of gas bubbles, we would get them because you do see a gas being formed. So yes, we would have it because it's the O2. Where would they be formed? They are being formed around the anode. And then the last question is just talking about where else can you see electroplating, and some obvious answers is like on jewelry, on cars, on houseware in terms of like your faucets, anywhere you're taking a more expensive metal and placing it are on top of a least expensive metal. As always, I hope you found this helpful. If you did, please subscribe. And if there's any other video I can ever do for you, just leave me a comment. Thank you for watching.